Hi, in this video we're going to look at conditional probability. And what makes conditional probability different is we're given some piece of information. So let's look at an example. Suppose that of the 24 students in a class, 82% like chocolate, 59% like espresso, and 53% like both chocolate and espresso. I'm in that category. What's the probability that a randomly chosen student likes chocolate given we know they like espresso already? So given is a really big keyword for this conditional probability. Also, if is another keyword, if we know they like espresso already. So I think a great way to show how conditional probability works is a Venn diagram. Let me draw one out. We won't be using those a lot, but I think a picture is really helpful in this case. So I'm going to make, we've got these two sets and we've got some overlap. So I'm going to make two overlapping circles because some people like both. And then let's define our variables or events. So let's make chocolate C and espresso E. So we'll have circle or set for chocolate, circle or set for espresso. And 53% like both chocolate and espresso. So just like in a table, how an and is the intersection, it's also the intersection of the set. So I'm going to put 0.53 in there. Now to find this region here, it's the people who like chocolate but they don't like espresso because we're already counting the 53% here. So we need to subtract. We're going to take 0.82 minus minus 0.53. Let's see what that is. 0.82 minus 0.53 is 0.29. So 29% like chocolate and they don't like espresso. Similar thing for espresso, we're going to take the 0.59 minus 0.53. Okay, that one I can do in my head because I don't have to borrow. So that is 0.06. Okay, so now let's see, how does this diagram help us out? What's the probability that a randomly chosen student likes chocolate given we know they like espresso already? So with this given information, we know they like espresso, so we're only going to consider this circle or this espresso set. So what it does is it changes our denominator, or it changes our sample space or sample size. So we're only going to be looking out of this amount. So what's the probability? First, let me write my probability statement. Probability that a randomly chosen student likes chocolate, so probability of chocolate, given, which is what this vertical bar stands for, we know they like espresso already. So this is red, the probability of C given E, or chocolate given espresso. So this bar literally means given. Okay, so what's the probability they like chocolate? So in terms of this circle only, well, these people don't, 0.06, they only liked espresso. So it's the 0.53 who they like chocolate because they like both. Over our total circle, remember these came from the 0.59, or if we add those back together, we get 0.59. So instead of using 100% for our denominator, we're going to use the given condition. 0.53 divided by 0.59 is 0.8983. Okay, so that's a conditional probability. Now there is a formula which you're welcome to use. I find a lot of students don't use it because we can do it kind of intuitively like we did this one. But I want to explain it. Some people like the formulas. The probability of A given B is equal to the probability of A and B divided by the probability of B. Now that's really what we just did. C given E was the probability of C and E. It was the intersection divided by probability of E. the given one, our total. Okay, so I hope the circle diagram helped. If not, no worries. I'm also skipping this. I've deleted it from the notes. You may have it or you may not. Okay, so let's look at this in terms of a table now. How do we find a conditional probability in a table? And we've seen this example before. We have an experiment where 72 chronic users of cocaine were randomly assigned into 3 groups. Cypramine and lithium were the treatments, and a placebo group. The results are summarized below. Okay, so if a person took discypramine, okay, so if, that's another keyword for conditional. If they took discypramine, we're only looking at either the row or column. In this case, it's a row. I'm going to circle that row. We're only concerned with this row, and that's why it says relapse. What's the probability they had a relapse? Probability relapse given they took discypramine. Notice sometimes the order of the sentence can be flipped. The given condition can be first or second. So just whichever one follows the key word. If a person took discypramine, that's the conditional. In our previous example, given we know they like espresso, espresso was following the given. So these are in 2 different orders. So the order in the sentence doesn't matter. It's where the if or given comes. So if a person took discypramine, what's the chance they had a relapse? So I'm going to look at relapse, and only in this row because we're only considering people that took discypramine. So that is going to be 10 out of our total, which is 24. And out of 24 is 0.4167. I got to round that one up. Or 41.67%. So in my open math, just as you're doing, just keep noticing whether they're asking for a decimal or a percent. And if it's something I'm grading, you can do either one. If a person took discypramine, they had a 41.67% chance of having a relapse. Okay. Let's look at another example. Given, whoops, given that a person had lithium. Okay, so again, we have a different keyword given, but it's the condition is coming first. What's the probability they had a relapse? So at this time, we have to write the probability statement. Probability of having a relapse. Whoops, didn't mean to do that. Given they had lithium. Okay, so now we are only looking at the lithium row. Given they had lithium, so again, we're limited to 24 people. And see, this is where it's really interesting to see, compare the different treatments. So conditional probabilities are used a lot. Okay, so in this case, 18 out of, put that one in green again, 24. 18 out of 24 is 0.75, 75%, much higher. If a person, or I could wrote given, if a person lithium, they had a 75% chance of having a relapse. Okay, great. So that is how you do conditional probabilities. There'll be another video with some more examples, because we also could do a column. One of the, given they had a relapse, or if they didn't have a relapse. So then we would use a column total. But before that, you're going to see a video on independence, which is really interesting. So I'll see you in the next video.